The last scheduling method that we will discuss in this class is called line of balance, LOB, and this is also known as linear scheduling or location-based scheduling. So why we call it linear scheduling or location-based scheduling? First is from its description. Line of balance is a diagram to show location and time at which a certain crew working on a given operations. So as you can see, previous scheduling method like Gantt chart, AOA, activity on arrow, or PDN, precedent diagramming method, activity on node, they only show the activity with time, the duration. But in this case, they show the location and time at which a certain crew working on a given operation. So it's not only time, it has location. That's why it's called location-based scheduling for line of balance. And this line of balance scheduling method apply to continuous activities, just like when you build or you schedule for irrigation system, doing canal works, railroad, road, etc. So it's for continuous activity. That why, and for a linear work or high-rise building, or it's linear, then that why it call it linear scheduling. So that's why line balance also called linear scheduling or location-based scheduling. So let's apply this in problem 2 in today. Problem 2. A 1 mile road project is to be built in Fort Myers, Florida. The road construction may be subdivided into 2 equal segments, a half mile each from 1 mile road. To complete this project, the contractor has created a required activities and estimated their duration below. Create a line of balance schedule for this project. Discuss the project duration. And again, the line of balance method can be used for any linear projects. In this case, the road, but irrigation system, water supply system, high-rise building, all of that can be used with this method. So we have 5 activities in this project. So let me abbreviate those activities so that we can easy to represent in the graph that we are going to draw. So the first one, the roof rate, let me call that is the RG. G for roof rate, and finish grade, let's call that is FG. And we have a concrete curb, let's call it CC. Aggregate base, let's call that AB. And lastly, we have an asphalt pavement, so we have it AP. Those are the 5 activities that we have. So if, and it follow predecessor successor relationship. So this activity have to finish before the next activity will be started. So let's see if we don't divide the road, only 1 mile, don't divide into 2 segments. So what it should be for the duration of this project. So let's see if we no division into segments. The first scenarios, if the road is not divided into 2 segments, as they call it in here, then what we have? We will have the activity like roof rate, roof grade, and we use the CPM, critical path method, roof grade. After roof grade finish, we can do the finish grade. Finish grade. And then we will have the concrete curve following concrete curb. And then we have aggregate based. And lastly, we have asphalt pavement, AP. Then we have this one for the whole 1 mile. We have this 8 weeks. This is 12 weeks. This is 12. This is 8. And 4 weeks for asphalt pavement. Then we can have the duration for this path is 8 plus 12 plus 12 plus 8 plus 4. We have 44 weeks. 44 weeks. The duration to do this road is 44 weeks. Now, if we use life balance, consider the 1 mile road is divided into 2 equal segments. How can we find out the duration for this project? And that is, you see the matrix of planning and the life balance. Planning is not only you just do the road without facing it. In this case, we face into 2 segments. So let's draw that down. So you see how much we will save from 44 weeks in the first scenarios that I just saw. So with that, we show the life balance method. So if you have location and time, so how can we do that? We can have a 2-dimension. The horizontal, it will be time, and in terms of the weeks, because that's what the problem gives us. And in the vertical, that will be segment. And we have 2 segments in this case. In this case, the segment or the location. And that's why they call location-based scheduling. So what does that mean? That when I show you in that scenario, so we have the road, let's say 1 mile. This is 1 mile road, and they divide into 2. So we have first segment, so we call that is segment number 1, and then we have segment number 2, and that is what they call it, divide into 2 equal segments. So 1 mile, 1/2 mile each of the total 1 mile. Then in the location, we have 2 segments, so we can divide that further into equal segments here. So let me call that is segment number 1, and that is segment number 2. And then from that, we can make a parallel line to divide those 2 segments along the durations, along the time axis, which is in weeks, horizontal line. Have it here. Then we now be able to complete the life balance schedule. And with that one, we can divide the time scale into segment. So let's do the time square in here. And each unit, we have 4 weeks. So let's do that. So it is 0, 4 weeks, 8, 12, 16, 20, 24, and 28. So with that, the definition of the life balance is a diagram to show location and time at which a certain crew working on a given operation. So let that one, the first work, it should be the rough grade Archie. And for 8 weeks, if we go for the 1 mile, so as you can see, 1 mile 8 weeks, then half a mile, segment number 1, we have 4 weeks, and segment number 2, 4 weeks. So what does that mean? If I have the 4 weeks in here, and we have 8 weeks, 12 weeks, 16, 20, 24, and 28. So the rough rate is 8 weeks total. So each, it will be 4 weeks, as I mentioned. So we have that start at 0. Start at 0. And then go through, finish after segment 1, 4 weeks, and let's continue that. It will be another 4 weeks, so it will be total 8 weeks. And this activity is called rough grade, as you can see in this schedule. And then the next one is finish grade, and that is 12 weeks. So each segment, it needs 6 weeks. So after the rough grade finish segment 1, as you can see here, the rough grade finish segment 1, then we can jump the finish grade into segment 1, and the rough grade continue in segment 2. So what does that mean? After rough grade finish segment 1, which is, let's show with the pencil here, go down, maybe so with that color, go down to this segment, and we can continue with the finish grade, and it's 12 weeks. So we have that is each segment is 6 weeks. So that is 6 weeks from week 4 to week 10, and then let's continue, and they will stop at week 16. So the finish grade. So that is finish grade, and the total is 12 weeks, as you show you in this schedule. And then similarly, we have a concrete curve that is 12 weeks, similar 12 weeks. So finish the first segment of the finish grade, then we can continue with the concrete curve, and each segment they need 6 weeks for the total 12 weeks. So with that one, we can have start at week 10 for first segment, it finishes at week 12, and the next segment number 2, it finishes at week 22, and that we call it concrete curve. And for the total 16 weeks. And the last one, or the last two, aggregate base, that is 8 weeks. 8 weeks. So this is important that we need to consider. Finish the concrete curve at the segment number 1, we can start with the aggregate base for the segment 1. So what does that mean? It means that we can do that, go down here, and we do the aggregate base 4 weeks for segment 1. So it means we can have that from here to there, and aggregate base. And then if we continue, if we assume we continue for another 4 weeks, so that it means here we go to continue that. We have a problem in these scenarios, because then if we have one time let's see that at time 22 weeks, we have both concrete curve and aggregate base occur on segment number 2, and that's not right. In one segment, only one crew should be working on. So in that case, as you can see, something wrong in between time 20 weeks and 24. For example, 22, we have 2 crew on the same segment. That should not be good. Let's see, give you one example. You do painting and you do the tiling in one room, and then it will be conflict on space. That's not good. So in that case, it's not reasonable. So there are a few ways that we can do. In that case, let me erase that. That should not be erased. We just keep continue that one here. There. Let's erase this line item. And then, because that problem, we can wait in until segment number 2 completed the concrete curve, and then we will start the aggregate base for 4 weeks. So let's move down here for 4 weeks. So that is aggregate base, and that can be considered discontinuous. So we finish aggregate base for segment 1 at week 20, and then we stop and move to wait for 2 weeks. With 22, we can continue aggregate base, and that we allow discontinuous work on one crew. If you want continuous work, if someone on site keep continuing doing it, then you can do the aggregate base for segment 1. Go down here, go down, not there, but it go down in 2 weeks and 4 weeks. It can be go down in give scenarios. That parallel. So either ways, the schedule will not change. It's still the last activity of aggregate base on segment 2 is finished at week 26. But this time it's more efficient if you move aggregate base on the segment 1, delay 2 weeks instead of start at week 16, which we start at early as possible. We can delay that in 2 weeks and start at week 18 and go continuously to finish the 2 segments. So that is one scenario. And then the last one is asphalt pavement, and that asphalt pavement is 4 weeks. So each segment it will be 2 weeks. So with that one, as you can see, we have scenarios here. Let's start with last segment. So we finish aggregate base in there. Then we can start the asphalt pavement for segment number 2. So we can have that start at week 26 and finish for each segment. It will be 2 weeks. So that is, as you can see, that is the asphalt pavement, because that total is 4 weeks, so it's 2 weeks. If you want to do continuous, then you can on the segment 1, you can start at week 24. So that is asphalt pavement for the segment 1. If you want to do it as soon as possible, then you can start this asphalt pavement after finish asphalt pavement. You can start this one here. So that is ask for payment. And if you want to do continuous, then of course we will follow this route. We will follow this route and we do when the payment and let pay for the whole thing. Then it start at week 24 and finish at week 28. So regardless of how you change in the segment 1, delay or start as early as possible, and you can see there the total duration for this project is here, which is 28 days, 28 weeks. So that from that one you can see the duration for this is 28 weeks. And compared to what is the original schedule, you have 44 weeks. And you can see with the good planning and using this method, we can able to save this project from 44 to 28, which is 16 weeks. Marvelous. Just divide the project into segment in this case. So good planning, and you can see save the project time.